Imagine waking up one day to discover that everything you know about the universe is wrong. Not slightly wrong but completely reversed. What if space isn't stretching outward at all? What if, silently and slowly, the universe is actually shrinking? Welcome to Information World. For decades, scientists have told us a single story about the cosmos. Galaxies are racing away from each other. Space itself is expanding. The universe began with a massive explosion called the Big Bang and has been growing ever since. This idea shapes how we understand time, space, matter, and even our own existence. But science has a long history of being humbled. Every time we think we've reached the final truth, reality surprises us. Now imagine a universe that is not expanding but contracting. A universe where the movement of galaxies, the redshift of light, and the fabric of space itself are misunderstood. This idea sounds impossible, even heretical, yet some physicists argue it deserves serious thought. If the universe is shrinking, everything changes, the fate of time, the destiny of matter, and the meaning of existence itself. To understand this possibility, we must first understand why scientists believe the universe is expanding in the first place. When astronomers look at distant galaxies, they see that light arriving from them is stretched toward the red end of the spectrum. This phenomenon is called redshift. The farther away a galaxy is, the more its light is redshifted. The standard explanation is that space itself is expanding, stretching light waves as they travel across the cosmos. This discovery, first made in the early 20th century, revolutionized science. It suggested that the universe had a beginning, a moment when everything was compressed into an unimaginably dense state. Over time, this idea evolved into the Big Bang theory, supported by cosmic microwave background radiation and the large-scale structure of galaxies. Expansion became the foundation of modern cosmology. But here is the critical question: is redshift really proof of expansion? Or could it be interpreted in another way? Some alternative theories suggest that light might lose energy as it travels through space, becoming redshifted without requiring expansion. This idea, often called tired light, was largely dismissed because it failed to explain all observations. Yet modern versions of similar concepts are being revisited with more advanced physics. In these models, space may not be expanding at all. Instead, the properties of light or space-time itself could be changing. Now consider a more radical possibility. What if space is contracting, but everything within it is shrinking at the same rate? In such a universe, rulers, atoms, planets, and even our own bodies would be getting smaller. Because everything shrinks together, we would never notice locally. Our measurements would still appear normal. Only when we observe distant objects would strange effects emerge. In this scenario, redshift appears not because galaxies are moving away, but because the universe was physically larger in the past. Light emitted long ago was produced when atoms were bigger. As that light reaches us now, it appears stretched compared to the smaller atoms we use to measure it. The illusion of expansion emerges from contraction. This idea may sound absurd, but it exposes something deeply unsettling: all cosmic measurements depend on reference standards. If those standards change over time, our interpretation of reality changes with them. Physics relies on constants like the speed of light, the size of atoms, and the strength of forces. If these values evolve, the universe could behave in ways that mimic expansion while doing the opposite. A shrinking universe also raises profound questions about time. In standard cosmology, time moves forward as the universe expands and cools. Entropy increases. Stars burn out. Heat spreads evenly. Eventually, the universe faces a cold, dark heat death. But in a contracting universe, the arrow of time becomes mysterious. Does time reverse as the universe shrinks? Or does time continue forward while space collapses? Some physicists suggest that contraction could lead to increasing order instead of disorder. Galaxies might grow denser. Structures could become more complex. In extreme cases, the universe could approach a final state of perfect compression, a mirror image of the Big Bang, often called the Big Crunch. Yet even the Big Crunch may not be the end. Some theories propose that a collapsing universe could bounce, creating a new expansion phase. This cyclic model suggests the universe has no true beginning or end, only endless cycles of expansion and contraction. If this is true, then our universe may be shrinking toward a future rebirth rather than an ultimate death. Now consider how gravity behaves in a shrinking universe. Gravity already pulls matter together. If space itself contracts, gravity's effects intensify. Black holes may grow more dominant. Galaxies could merge faster. The cosmic web could tighten like a net being pulled inward. The universe would become a more violent, energetic place over time. This raises another disturbing possibility. What if dark energy, the mysterious force believed to drive expansion, does not exist at all? Dark energy was invented to explain why expansion appears to be accelerating. But if expansion is an illusion, then dark energy may be unnecessary. The universe may be obeying simpler laws than we think, while our interpretations complicate the picture. Some physicists argue that modern cosmology relies too heavily on assumptions. We assume constants are constant. We assume large-scale uniformity. We assume our position in time is not special. But if any of these assumptions fail, the entire framework collapses. A shrinking universe challenges all of them at once. Now think about what this means for humanity. If the universe is shrinking, our cosmic future looks very different. Instead of endless isolation as galaxies drift apart, everything eventually comes closer together. The night sky would grow brighter over billions of years. Distant galaxies would appear larger and more detailed. The universe would feel more intimate and more dangerous. Advanced civilizations in such a universe might face unavoidable cosmic compression. Energy densities would rise. Radiation would intensify. Survival would require mastery over gravity, spacetime, and perhaps dimensions beyond our own. In this context, intelligence itself becomes a temporary phenomenon, struggling against the collapse of reality. Philosophically, a shrinking universe challenges our sense of progress. Expansion suggests openness, growth, and possibility. Contraction suggests inevitability, convergence, and fate. Are we moving toward freedom, or toward a final point where everything becomes one? This idea resonates deeply with ancient philosophies. Many traditions describe the universe as breathing, expanding, and contracting in cosmic cycles. Creation and destruction are not opposites, but partners. Modern physics may be rediscovering truths that ancient thinkers intuited through myth and metaphor. Yet science demands evidence. At present, the shrinking universe remains speculative. Most observations still support expansion. But history teaches us humility. Newtonian physics ruled until Einstein rewrote gravity. Classical mechanics failed at atomic scales. Certainty in science is always temporary. Future observations may reveal subtle clues. Changes in fundamental constants. Unexpected patterns in cosmic background radiation. Anomalies in distant supernovae. Any of these could hint that our cosmic story is incomplete or inverted. If the universe is shrinking, then we are not living in the aftermath of creation, but in the approach toward convergence. Every moment brings the cosmos closer together. Every second compresses the stage upon which existence unfolds. The universe would not be running away from us, it would be closing in. And perhaps the most unsettling thought of all is this: if the universe is shrinking, then the Big Bang may not be the beginning of everything. It may simply be the midpoint. A turning of the cosmic tide. A moment when contraction became expansion, or when expansion began its long return inward. Reality may not move in straight lines. It may move in loops. So the next time you look up at the stars, remember this. What you see may not be galaxies fleeing into the void. They may be echoes of a larger past, drifting toward a future where everything meets again. The universe may not be growing apart. It may be slowly, silently, coming together. If you enjoyed this journey into the deepest possibilities of the cosmos, make sure to like the video and subscribe to the channel. Your support helps Information World bring you more mind-expanding ideas about reality, science, and the universe we live in.